This problem is perhaps slightly more challenging. Let's read through it. A car can drive 344 miles in the same time as an airplane can fly 774 miles. The plane averages 80 miles per hour faster. How fast is the car averaging, or how fast is the car driving? And this, what I have in mind when I wrote this, figured out this problem is this is a small plane like a Cessna, and so they don't go that fast, but they do go faster than cars, ordinarily, of course. All right, so again we have two trips, one by car, one by plane, and we don't know how fast is the car going. Well, when I tried to define the equation for the car, I'm going to need the speed, the time, and the distance. And I do have the distance. I don't know speed and time. So how about we go ahead and call x. Let's let x equal to the speed of the car. And while we're at it, how fast is the airplane going? 80 miles per hour faster. So if I add 80 to this, x plus 80 is the speed of the plane. And when we write these, let's use miles per hour again, because that's what this is in. So I'll write the units in as we go, but we could say in miles per hour. We're also going to need time, and it is the same time for each trip. So I'd like to use t for time. So I'm going to let t equal to the time for either trip. Since it's the same, I can get by with one letter for time. I can't get by with x for car and plane because the plane is going faster, so I have to change that to x plus 80. So here we have the car, and it drives. I was about to write drives. Let me write drives. Drives x miles per hour, and I want to multiply by the time, t hours, and once again this is going to cancel off and give me miles. That's x t miles. But what we also know is that his distance is 774 miles. So, multiplying these is the correct thing to do because it gives me miles, but I have another way of, and I wrote the wrong number, didn't I? Let me fix that. The car didn't go that far. It went 344 miles. Okay, so his speed times time was 344 miles. Well, in the algebra, that's x times t. So there's one equation. xt equals 344. The plane flies. It's not driving, it's flying. It flies, x plus 80 miles per hour for the same amount of time, t hours. Same time, so I can get by using the same letter here. I'd like to stress that because I've had a lot of students use one letter for two different quantities. If you use, suppose it took longer for one of these vehicles than the other one, if the times are different, you can't use the same letter to represent the different times. You would have to alter it some way, just like we altered x miles per hour down here and call it x plus 80. So I've seen students do that a lot, and because they weren't thinking through that. All right, so that equals to, and my board is pretty cluttered here, but I know it's 774 miles. So we have this algebra equation equals 774. Again, I hate having to do this on a little tiny board, and because it gets cluttered and I have to do some erasing. And but that's just the luck of the draw here. All I can do. But in my book, the problems I work out, I do spread it out kind of nicely, the way you should. So, you know, don't cramp your work. When you cramp your work, most people are prone to some errors they should not make. All right, when you clutter your work. So careful there. Paper is cheap. You know, I would use it. All right, now I assume you have this down. I'm going to erase it and finish the problem. So we want to know how fast is the car going. Okay, so make some room. And what we have is these two relationships. We have xt equals 344. And then we have x plus 80 times t equals to 774. So now this time I ended up with two equations with two unknowns. And now in the previous video problem I did, we ended up with one equation with one unknown. And the difference is that in the previous problem, the distances were equal, and so we really eliminated the distance variable by setting those equal. I could do that here. If I solve for t, you know, t would be 344 over x, and t would be 774 over x plus 80. I could set those equal to each other. That would eliminate the t's, and then I'd have an equation with just x's in it. That would work great. There's other ways to think through this. We could actually divide equations, which is kind of weird, but if I divide these equations, the t will cancel off. So I'll get a fraction equal to a fraction, and we could go from there. Probably the most natural thing to do would be to multiply. And here multiplying works well because I'll have an xt term, which I can substitute for, and then I'll just have a t term. So I could do that to solve for time if I wanted to. So there's about a couple ways to solve this problem. I really think that might be the easiest, although it's a little more of a roundabout way. So we're going to have to, I have to do some erasing, but hopefully you've taken a few notes watching this. And you'll do better if you take notes, just like you were in class taking notes with these videos, instead of just watching it like an ordinary movie. All right, so make some room here. Now, if I multiply this out, I get x times t plus 80t equals 774. And here's the substitution I want to point out. I know what xt is. Xt is 344. So I can substitute right there. Replace it, 344 plus 80t equals 774. So if I subtract 344 from both sides, I get 430, I think. Is that right? 430, yeah. And then solve for t, divide by 80. And t would be 43/8. Now if you want to call that 5 3/8, that's okay. In decimals, that would be, I think, 5.375. Whatever the case, I'm just going to leave it that way. But I can now solve for x by taking that up to one of these equations, and this would be the easier equation. So if I replace t with this value, I have x times 43 over 8 equals 344. And let's see, we can multiply both sides by 8. That will cancel the fraction. And let's see, 8 times 344 is 2,752. 2,752. So I have 43x is 2,752. And now divide both sides by 43, and I hope it comes out to a nice whole number, because that's the way I designed the problem. Yes, it does. It cancels very nicely. X is exactly 64. Now, was that what we were looking for? I believe it was. So the car was going 64 miles per hour because that's what x represented. So I'm going to write out the answer, and then let's check it. And again, I want to stress how you check these things. So the car averages 64 miles per hour. Alright, so there's the answer, and notice I put a period at the end of the sentence. You know I make a big deal of that is because if I don't say anything, about half of my students will not put a period at the end of a sentence. It's just laziness, mental laziness. And very, it's careless. And you want to build good habits, because as you go into the responsible work world, if you're going to be a manager, if you want people to take you seriously, you've got to write like you mean it. Be serious about how you write things, how you communicate. All right, now how are we going to check this problem? The car went the same distance. I'm sorry, the car went 344 miles in the same time it took the airplane to go 744 miles. All right, 774 miles. I forgot my number already. All right, so let's check that. Now, if you went 5 3/8, that's 5.375 hours. So I have miles per hour times hours. So we've seen that before. Hours cancels. And I just want to double check. At that time, and that speed, I get 344 miles. So again, this is miles per hour times hours. Now the airplane going 80 miles an hour faster is going 144 miles per hour, same amount of time. So 144 times 5.375 is 774 miles, which agrees with the statement of the problem. So speed times time are the correct distances, and so this problem has to be correct.